Is f of x a formula? Many students think it's a formula, but actually it is not. I will explain to you what a function is. Now have a look at this slide. You have two functions, one is f and another is g, and f has the instruction to add 2 and g has the instruction to multiply by 2. Now naturally you will be searching for your favorite, where is f of x and where is g of x. Am I right? But I am writing only f and g and call them as a function. What I mean by f and g and what I mean by f of x and g of x, what is the main difference? See, f is a function, you think it of a machine with an instruction to add 2. To what? To an input. When you add an input, for example, x, you add the input to the function or a machine, it takes the input, now it is called f of x. Now, you this apply the rule to the input which is added to. So, you get the output. Similarly, x is the input applied to the function g. G applies the rule on the input x and the output is 2x. Now you got the point. So what is been written within the bracket is the input. It's not a function itself. So both f and x combined together will just run. That will be a function with equivalent output. Now if you see f of x, for example, we will say f of x is equal to x plus 2 in this case and g of x equals to 2x. See, that's how you now understand a function. Generally, when you see a function like f of x, don't see it in abstract way, but just think like this: x goes to f, and that the rule of f is applied on x, and you get the output. This is actually what a function means. Now I will introduce one interesting concept, a composite function. Look at this: f of g of x. Here is x is the output. And what do you say? What do you see actually? Two more functions are there, no? F and g. Here we have seen only one function. F here in this case g, but here you see two different functions. So when more than one functions, two or more, process one input, we call that as a composite function. It is not output, it is input. I'm sorry. That is called a composite function. And what is the rule for evaluating composite functions? It is so simple but very important. Just start from the right, goes to left, 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 until you get outermost function. Outermost function. What is innermost and outermost function? Innermost function. Now take a larger function, f of g of h of k of x. So in this case, the input x first gets processed by k, the innermost function, so k, then goes to the left, that is h, then to g, and finally the outermost function f. So this is the rule. So now I will explain to you with one practical example, f of g of x and g of ef of x. Now you will understand it much better. So x is the input both the cases because we written in the bracket, so x is the input. So the innermost function in this case is g. So g of x means the output is, we all know 2x because it's multiplied by 2, we are already defined here. Na? This we are going to use, it is 2x. Now where the output goes? It goes to the function f. What does the function f does? It just adds 2. So the output becomes 2x plus 2, which is the output of f of g of x. You can write like this also and you can write like this also. So now we'll go to g of x. So again the input is x. So process f being the innermost one, process it and it adds 2 as per the rule and it gives the output to g. G process it, takes the input and process it by multiplying the input by 2 and gives us 2x plus 4 as the output, which is g of f x, g of fx. You see, 2x plus 2 is not equal to 2x plus 4. Therefore, f of g of x is not equal to g of f of x. Generally, it is not equal. There are some exceptional instances that we will decide later on. We will discuss later on in our next video. So, f of g of x is not equal to g of f of x. It means that the commutative law doesn't work on functions generally. But however, the associative law works. Why and how? This is also the logic. There are absolutely no magic, only logic. Why? Should immediately ask why f of g is not equal to g of f. Don't accept blindly, whoever says. See here, the input is first processed by g and then processed by f. However, in this function, composite function, the input is processed by f first, then by g. So now you look at it. No? Here itself it changes. The very first step itself, no? It is g of x and f of x, and it is here 2x and it is x plus 2. Therefore, the output will never be the same except in rare cases. So, generally, commutative property, commutative law does not work with functions, but associate law does. What is that? F of g of h is always equal to f of g of h. Why do we say so? Even though we group f of g and g of h, the processing is same. The, the sequence of processing is same. Here, you see, given that you give x to both the functions as input. This function also, the innermost is the rightmost function, that is h. So h process the function first, then processed by g, then processed by f. Here also you see, give x as input, first processed by h, then processed by g, and then processed by f. Here we don't change the order or the sequence of processing of the input. Therefore, that associative property always holds good. Whenever you change the sequence of processing, then definitely the output will change. Therefore, the commutative property or commutative law does not always hold good for functions. So now what you do is you try create your own function rule like add 3 or multiply by 5 and write in the comments what you get. I will reply to you, and in the next video we will solve real composite function questions. And subscribe to the channel so you don't miss any updates, and learn mathematics by rules and concepts and not by memorization. Thanks a lot for watching.